Hello students, welcome back to Tutoratti. This is the live session brought to you by Tutoratti on atomic structures, and this is our fourth session, and it's a very good response that we have got from you guys, and I'm very glad that you guys are enjoying it and appreciating it. Thank you very much. So please tell me when you arrive, at least say hello so that we can interact in a better way. Hello Sarthak, good evening bhai. Hello, how are you? I hope your studies are going well. Hello Jayant, welcome back. So in the last session, in the last three sessions, we have studied the basic models, that is the Thomson's atomic model, Rutherford's model, and we also got to know about a little and about the Maxwell's theory and how it was not very good, and we disproved it with some experiments, black body radiation and Wien's displacement law. Okay, today we are going to study a very important topic. Good evening Pranit. We are going to study a very important topic, that is Max Planck's quantum theory and photoelectric effect. Exactly, the topic of today's discussion is photoelectric effect and Max Planck's quantum theory. We'll go ahead and start with Max Planck's quantum theory. Let's start. The first thing is experiment related to quantum. The first thing, assume a ball is being dropped just like this. See this, it is being dropped. Now assume what will be happening to its potential energy. क्या हो रहा होगा इसकी potential energy को? क्या होगा? At each point when the ball is moving from here to here, at each point I can calculate the potential energy. At each point I can calculate the potential energy. So what can I say? What can I infer from this information? That the energy is continuous. Okay? Because I can calculate energy at this point also and this point also. I can infer that energy is continuous. Okay? Potential energy is calculated by MGH, you already know it. So the potential energy, all the values can be calculated. Now assume this one, the ball on the stairs. Now what will happen? It is dropping, again it's dropping, and again it's dropping. So at this vertical point, can you calculate the potential energy at this vertical point when the ball is dropping? When the ball is dropping from here to here or here to here, you cannot calculate the potential energy because it is not, but the ball is not stable there. You cannot calculate the potential energy. That is why by this experiment I can say that the potential energy at some values cannot be achieved. So I can say that energy is discontinuous also in a manner. Here the energy was discontinuous, and in this way energy was discontinuous, and our Max Planck also told us that energy can also be discontinuous. Okay, this is continuous, this is discontinuous. Now let's move ahead and check the quantization of energy. What is the meaning of quantization? What is the meaning of quanta here? The word quanta. Can you tell me what is the meaning of quanta? Tell me quickly. Anyone? What is the meaning of quanta? Let's see. Okay. Good. Quanta is the smallest unit of anything. Like हमारे आज जो करेंसी चलती है इंडिया में, उसका क्वांटा विच इज एप्लीकेबल, ये सार्थक, दिस इज नॉट ओनली रिलेटेड टू लाइट. क्वांटा इज द स्मॉलेस्ट यूनिट. क्वांटा इज द स्मॉलेस्ट यूनिट. जैसे करेंसी का क्वांटा क्या है? 1 रुपए, जो आजकल प्रैक्टिस में है. अकॉर्डिंग टू अथॉरिटीज इट्स 50 पैसे, बट इन रियलिटी it's 1 rupee. The quanta will be 1 rupee. If energy is discontinuous, it can also be quantized. If energy is in the form of discontinuous form, then I can assign a minimum value to energy also. That's what Max Planck did. What he did, that energy emitted by heated bodies. Yes, this is the very good example. When a body is heated, the energy which radiates from it is in discontinuous form. Okay, so this is called if I try to discontinuate the energy, it will be called quantization of energy. And at one time, one quanta of energy, that is one particular energy, can be supplied to one electron. See this. This is the electron and this is one energy packet, one quanta of energy. Only one can be supplied to this electron, not the two quantas. Or the same quanta can also not be supplied to two different electrons. So the quantum of energy which cannot be divided, as I told you, if the quanta is already the smallest unit, you cannot divide it. You cannot use the 1 rupee at two places. Similar way, this quanta can also not be supplied to two electrons. No, it will only be supplied to one electron. So how will we quantize the energy? According to Max Planck, the energy of light or electromagnetic radiation is directly proportional to nu. What is nu here? Do you remember this expression? E is directly proportional to nu. What is nu here? What is this expression? Tell me quickly. What is this expression? E is directly proportional to nu. What is nu here? Sarthak, Pranit, Jayant, tell me. Very good, Nivedi. This nu is actually the frequency. This is frequency. Let's go ahead. Have you seen any relation between nu and lambda? That is frequency and wavelength. Good, Pranit and Sarthak. It is frequency. Have you seen any relation between nu and lambda? That is wavelength. The relation will be this. Nu can also be written as C by lambda, because nu into lambda is equal to C. We saw in the earlier sessions. Now, if I remove the proportionality sign, I will have to put a constant here, and that constant will be called H. It is represented as H and called Planck's constant because it's his theory. If I had given it, I would have given it my name. Duh. This is called Planck's constant. Okay, and I can also write it as E is equal to hc by lambda. E is equal to h nu, E is equal to hc by lambda. This is the energy of one photon or one quanta, only the energy of one photon. If I have to calculate, there are n number of photons coming at me, and I have to calculate the energy of entire photons, all the photons, then I will have to add the number of photons also. So I can write it as, before that, the value of Planck constant, it is very important that you remember this value. It is 6.62 into 10 to the power minus 34 joule second. 6.62 into 10 to the power minus 34 joule second. You have to remember this value. It will be used in your numericals. Okay. Now, if I am using n number of photons, then the total energy will be n times of h nu or n times of hc by lambda. So the entire energy will be nh nu or nhc by lambda. This is the second formula. N packets, n number of photons. There are two rules that you have to understand. One thing, at an instant only one quanta can be supplied. Only one quanta can be supplied, as we saw in the earlier slide also, that it is approximately that, Pranit, 6.627, 6.626. It's okay because we do not use it, we only use it till 2 decimal places. The third is generally not considered, otherwise we would have taken 6.63. In the calculations, always use 6.62 and that is enough. Okay? Good. So the first thing is only one quanta can be supplied to a particle, and the second rule is it cannot be distributed. One quanta will be supplied to one particle and that quanta cannot be distributed. These are the two rules that you have to remember. And now let's revise. NHC by lambda, due to quantization, Maxwell's theory got disproved. This is how also we disprove Maxwell's theory, because according to Maxwell, what was Maxwell saying? The wavelength will not change, frequency will not change, only the intensity will change. How can you change intensity without changing nu or lambda? That is how Maxwell got disproved. Okay, so important values that you have to remember. H is 6.626 here. Here it is written 6.626. So it is interchangeable. You have to remember it till 2 decimal places, because in numericals you will use only till 2 decimal places. 6.626 into 10 to the power minus 34 joule second. Next one is C, which you already know, the speed of light, which is 3 into 10 to the power 8 meter per second. And if you have to save your time, just remember this value of H into C. It will always be helpful. It will always come handy when you come to the calculations. Always. 3 into 6.62 into 10 to the power minus 26. This value will save your time. This is approximately what, 19.8. Yeah. Then HC can be, yes, 2 into 10 to the power minus 25, because 19.8 is approximately 20. Yes. HC in electron volt can be this 1242 electron volt nanometer. How can we calculate electron volt? Just what? Just divide by the charge of electron and you will get the value in electron volt. What is the charge of electron? 1.6 into 10 to the power minus 19. You will get this value, and then potential energy, that's okay. As I told you, you just have to divide by 1.6 into 10 to the power minus 19 and you will get the value in electron volts. Remember this 1242. It's quite, catchy also, 1242. So you will remember it. Now let's go to a very important topic that we have to study, is photoelectric effect. Now, what is photoelectric effect? Let me make you understand. Okay. Now, suppose this is your nucleus. Okay, let's try from this side. This is your nucleus, and as we know, electron revolve around it इतना हमें पता है, इतना हमें पता है, ठीक। लेट्स सपोज दिस इलेक्ट्रॉन इज अ व्हाट, बॉन्डेड लेबर, बंधुआ मजदूर है ये, क्या है, bonded labor. The electron is the bonded labor and this nucleus is the lala. Lala is what? The local zamindar to which the electron owes the money. ये इलेक्ट्रॉन के ऊपर कर्जा है लाला का. Now what electron is doing, electron is doing the continuous bonded labor without any money. Now one day you visit the village और आपका दिल पसीज गया कि भाई बेचारा इलेक्ट्रॉन बंधुआ मजदूर बन के तड़प रहा है, काम किए जा रहा है, he is just doing the work for free, only getting 2 times of food. So you decide I will free this labor, I will be the man जो कि मैं इसको फ्री करवाऊंगा. Okay, you ask electron, how much do you owe the lala? He says, I owe 10,000. You say, okay, take 10,000 and be free from the chains of this lala. You decided to go the 10,000 to electron. Okay, you gave 10,000, दे दिए, जा जी ले अपनी जिंदगी. You give 10,000. What will happen? This 10,000 electron will give to lala and be free. Okay, but what after that? What after that? उसके बाद क्या होगा? Electron have to eat. भाई कुछ तो खाना होगा इस इंसान को. And if have to eat, there is no other source. He has no money because he was not being paid. If he has no money, how will he pay for the food? He will again borrow from lala and be again in debt of lala. लाला के कर्जे में फिर से फंस जाएगा. That is no solution. You freed the electron and again the electron had to come back to nucleus. What is the way in which you can free the electron? Or I can rephrase the question, how much money you should give to the electron so that the electron will be free from the clutches of lala, that is nucleus. How much money should be paid? Tell me. How much money should I pay to electron कि भाई जा सिमरन जी ले अपनी जिंदगी, so that he will not be in debt of this lala? How much money? Tell me. Remember, the debt is 10,000. Tell me quickly. More than 10,000. Pranit says more than 10,000 and it's quite correct. Yes, Nivedi, more than 10,000. Is it any particular value or anything more than 10,000 will work? Tell me, guys. Tell me. Okay, I'm waiting. Yes. I haven't gone on mute. I'm just waiting for the answer. Anything above 10,000 will work. Okay. Anything above 10,000 will work. And this is the exact scenario of photoelectric effect. Exact scenario. No, Pranay. Anything above 10,000 will work if we want to free the electron. Exact 10,000 will not work. Anything above 10,000 will work. 10,001 rupee, 10,002 rupee, 10,003, 11,000, 12,000. If you are too much Amir, give 1 crore also. minimum value should be 10,000 exactly. So how does this photoelectric effect work? Just understand this by this slide. This is a metal surface. What happens in metal? Electrons are loosely held at the surface. Electron will be present loosely held on the surface, and you are providing an energy to the metal surface. A radiation in the form of photon is being provided to the metal surface. Now what will happen? The electron will receive the energy. As I told you earlier that electron gets energy from only one photon. This radiation, one photon will strike with the electron and pass on the energy to the electron in the form of the debt repayment. Just like the energy, just like the money we were giving electron, here in the form of here in this experiment, in case of money we are using energy. Energy is provided to electron. What will happen? The 10,000 electron will use to repay the debt of this metal, because the electron is bonded with this metal by some forces, and if the electron has to overcome the forces, he will have to use the energy to overcome that. So a part of energy given to the electron will be used in overcoming the bonds, and the rest of the energy, what will electron do? Run away. अब भाग लेगा ना. He will use the rest of the energy to run away. Some energy will be used to overcome the bond, and the rest of the energy will be used to overcome the to run away, or in this case to increase the kinetic energy. It will be used to increase the kinetic energy of the electron. It means if I am giving you certain energy E2, then E1 will be paid to metal to overcome the force of attraction, and the rest energy E dash will be used in increasing kinetic energy. Some amount of energy will be used in overcoming the force, and the rest of the energy will be used in increasing the kinetic energy. And this is how the photoelectric effect works. Okay, let's move ahead. Now, energy of the electron increases because you have supplied the energy. How does the experiment looks like? Let me tell you. This is how the experiment looks like. This is the cathode, which is actually the metal on which we will incident the radiation. This is the metal on which we are incidenting the radiation. Why are we using the monochromatic light source? Because we want only one lambda, that is only one wavelength light. Such light will be called monochromatic light. Yes. So whenever the light will strike on the metal, an electron will be ejected. Why? Because we have freed the electron. We are the savior of electron. So the electron will be freed, and as soon as the electron gets freed, imagine this is the electron which is coming out. Now this is a positive end. Electron is negatively charged. The electron will be attracted towards the anode, and as the electron reaches the anode, there will be a reading in the galvanometer, and you will know that yes, some current has been passed. And when the current will be passed, you will get to know there was an electron ejected, and thus we know that photoelectric effect is happening. Why are we using, see, photoelectric, photo for photon, and electric means electricity. Due to photon, I am producing electricity. That is why this experiment is called photoelectric effect. Okay? I hope this clears it. If you have any doubt, please tell me. Let's move ahead. This is the entire experiment. Electron came out, went to the other terminal, and then electricity will be passed in it. Photoelectric experiment. Now, there are some different conditions which is not, I will tell you the exact conclusion, not the middle story inside it. What was the ultimate condition is that, sorry, look at this metal. The minimum energy required to remove an electron is called work function. Work function. That is the minimum energy required to just remove an electron. Just remove an electron. If I have to just remove an electron, the minimum energy required is called work function, and it is described as phi. It is described as phi. And I am supplying an energy. What will be the rest of the energy in used? The rest of the energy will be used in the increasing in kinetic energy of electron. Okay? I am supplying h nu energy. Okay? And some amount of energy is being used as work function to remove the electron, and the rest of the energy electron is using in kinetic energy. So can I say this energy will be used in two things? As I told you, E2 is equal to E1 plus E dash. H nu will be equal to phi plus kinetic energy. That is work function plus kinetic energy. Okay? Tell me, if the electron needed 10,000 rupees, what will happen if I give 9,000 rupees to electron? Tell me. What will happen if I give 9,000 rupees to electron? कुछ होगा क्या? लाला उसको जाने देगा कि जा तेरे 1,000 रुपए माफ कर दिए? बोलो, बताओ बताओ. Tell me guys, क्या लाला उसे माफ करेगा? Will not move out. Exactly, Sarthak. 9,000 will have no effect. 9,000 will have no effect. इलेक्ट्रॉन की लाइफ पे 9,000 का कोई इफेक्ट नहीं पड़ने वाला. It means the minimum energy required is phi. So the minimum energy required to remove the electron will be work function, and the minimum frequency required, let me just tell you, the minimum frequency required, minimum frequency required is called threshold, frequency, and is denoted by nu naught. ऐसा. And if a frequency is attached to an energy, a wavelength will also be attached to it. We all know. So the maximum wavelength required is called threshold wavelength, and this threshold wavelength is called lambda naught. So the energy will be, minimum energy will be h nu naught. Minimum energy is what? Phi is h nu naught or hc by lambda naught. If we go to the initial equation, h nu is equal to phi plus kinetic energy, replace phi, we get h nu is equal to h nu naught plus kinetic energy, and we can also write hc by lambda is equal to hc upon lambda naught plus kinetic energy, and this is the relation of photoelectric effect. This is the relation that you will be using in photoelectric effect. And believe me, in JEE Advanced, the question has been asked on this work function. In JEE Advanced, there is already a question asked. Check your previous year questions and you will see a question on work function. Okay? Good. Do you guys have any doubt till now? Please feel free to ask. If we only supply work function, then electron will move out and will again move inside. Yes, because Sarthak, if I am supplying the energy just equal to work function, then the electron will just be out. If electron is just out and electron has no energy left, then the nucleus will again pull it back. You have just freed it, but the electron has no energy. Electron has no energy. So the nucleus will pull the electron back. But if you use it in the experiment, if you are using the same thing, let me just tell you, if in the experiment, if you have provided just the same energy, just equal to work function, electron will just come out and it will be attracted towards the anode, because in this case you are applying the electric field. In normal case, the electron will go back inside, but in this case you are providing an electric field, so electron, there is someone which can attract the electron, so the electron will go towards anode if you are providing work function, energy equal to work function itself. Okay? I hope I have answered your question. Now I have told you different, these were the observation of Einstein, and I have told you already the summary of it. There is a threshold frequency required below which there will be no photo emission, and there is also a frequency at which there may be emission of photon, but the intensity will be low. Now let me tell you what is the difference between the intensity and energy of photon. Intensity means the number of photons are more. If I am talking about the intensity, it means number of photons are more. What will happen? Suppose the work function of a metal is 4 electron volt and I am supplying energy 3.9 electron volt and I have quadrupled the intensity of photons. 4 गुना कर दिया मैंने इंटेंसिटी. क्या फोटो इलेक्ट्रॉन निकलेगा? will there be any ejection of photoelectron? Yes or no? Work function is 4 electron volt. Energy that I am supplying, the energy of photon is 3.9 electron volt, and I have quadrupled the intensity. Will the photon will come out? Will the photon come out or not? Tell me. Yes, you are quite right, Sarthak. Electron will not come out because you are not providing enough energy. Because one electron will only get one photon, and you are not increasing energy of one photon. You are increasing the intensity. It does not matter to electron whether you are providing n number of photons, because for electron only one photon matters, and the energy of that photon should be equal to 4 or greater than it. Then only the ejection of photon will happen, else it will not happen. I hope this concept is clear, because this question has been also asked in the previous examinations. This is a very conceptual problem. I hope it is clear. Increasing the intensity does not guarantee the electron will come out of the metal. You will have to increase the increase the energy of photon. Then only the electron will come out. Okay? So, this was from today's session. I hope you have enjoyed this, because it was very conceptual topic. And in tomorrow's lecture or day after tomorrow's lecture, I will tell you, we will discuss some problems on this concept, and we will also try to understand what is the spectrum. So the topic of the next lecture is going to be spectrum. Make sure to like, share and subscribe to Tutoratti JEE. Stay tuned, and we are going to study atomic structure together, and we'll try to revise the entire concept. If you have missed any lectures, go back to the playlist and watch all the lectures, and stay tuned. Thank you.